Imagine stepping into the glass wall boardroom of a major multinational logistics firm on a Tuesday morning. The air inside the room is thick with panic. The chief operating officer is pacing back and forth across the carpet, clutching a stack of client contracts. On the speakerphone, a senior corporate counsel is explaining that over the weekend, the company's automated customer onboarding pipeline systematically generated and dispatched 84 legally binding service level agreements to new enterprise accounts. The problem? Every single one of those contracts contain completely fabricated, financially catastrophic terms. In one instance, the system automatically guaranteed a premium global shipping client a 100% refund if their cargo was delayed by even a single minute, citing an obscure internal corporate policy code that does not exist anywhere in the company's history. In a frantic attempt to find the culprit, the executive team rounds on the technology department. They demand to know who updated the underlying application code. They wanted to know if the central server infrastructure was breached by malicious actors or if the database was corrupted. But when the cloud system architects pulled up the server logs and inspected the raw API data payload sent to the large language model over the weekend, they find absolutely nothing out of the ordinary. No security keys were compromised, the data pipelines were running completely clear, the inputs provided by the human operators were perfectly formatted, accurate, and clean. Instead, the entire multi-million-dollar operational collapse can be traced back to a single line of configuration text buried inside a background system integration file. A software engineer, while migrating the system from a sandbox environment into the active cloud production, forgot to explicitly define a parameter known as temperature. Because this variable was omitted, the enterprise system defaulted to a standard configuration value of 1.0. To a regular business professional, the difference between a 0 and 1 feels completely trivial. But inside the delicate architecture of generative artificial intelligence, that tiny configuration omission acts as an invisible financial bleed, silently destroying data integrity, derailing operations, and wasting thousands of developer hours. Welcome back to the AI desk. If you are an operations director, a human resource manager, or a real estate professional, you have likely been told that when an AI system gives you bad or erratic response, it is simply because you did not phrase your prompts correctly. The tech industry loves to blame the user. They tell you that you need to find the magic words or that you need to write a longer, more descriptive paragraph. I'm here to tell you that phrasing is only half the battle. If you do not understand the underlying mathematical parameters that govern how an AI selects its words, you are essentially driving a high-powered sports car without a steering wheel. Today, we are stripping away the confusing industry jargon to master a foundational concept that every executive must understand if they intend to scale operations safely: temperature dial dynamics. Our core topic for this entire session is simple: adjusting AI output parameters from rigid mathematical logic to wild creativity. When you open a consumer-facing AI application or interact with an enterprise system, the software vendor hides the structural control behind a sleek, minimalistic interface. They give you a blank text box and expect you to do the rest. But behind that text box sits a hypersensitive configuration engine. By learning how to explicitly manipulate the model's temperature, you stop hoping for a good response and start engineering it. You learn exactly how to transform the AI from an unhinged, overly creative storyteller into a cold, hyper-literal compliance clerk, or vice versa, depending entirely on the exact needs for your business workflow. Think about the hidden costs currently quietly draining your company's efficiency right now. Your customer service department might be utilizing a text model to generate automated email responses to billing disputes. If the temperature parameter inside the connection is set too high, the model will constantly invent polite but completely inaccurate promises, forcing human supervisors to spend hours unscrewing the mistakes. On the flip side, your marketing team might be using the exact same text model to brainstorm hooks for a new advertising campaign. If the temperature parameter in their portal is locked at 0, the model will spit out the exact same dry, uninspired robotic phrases every single time they hit enter, rendering the tool completely useless for creative ideation. This hidden friction costs global organizations thousands of dollars in lost compute credits and engineering remediation every week. It creates an underlying sense of intimidation and mistrust among non-technical workers who conclude that AI is simply too unpredictable for serious corporate tasks. But this unpredictability is an illusion. By the time we finish this session, you will possess a complete structural blueprint of how to govern this digital energy, allowing you to run your operational desk with absolute architectural precision. To truly understand how the temperature parameter alters the behavior of an artificial intelligence system, we must look beneath the user interface and look directly into the core word selection mechanics defined in the official developer docs. In this case, I am referring to the Anthropic Developer docs. Let's completely bypass the traditional dense programming structures and explain the heavy backend data flow through a vivid physical analogy that you can easily picture. I want you to imagine a professional kitchen. In the center of this kitchen sits a massive, heavy industrial stove. This stove represents the generative AI model. On top of the stove rests a large pot filled with water and thousands of tiny little plastic tiles, with each tile representing an individual word or a piece of word, what we call a token. Now, our goal as a supervisor of this kitchen is to use the stove to select a sequence of tokens to build a clean corporate policy statement or a creative advertisement. The control dial on the front of the stove is a temperature parameter. In the Anthropic API architecture, this dial can be turned anywhere from a value of 0.0 all the way up to 1.0. Let's turn the dial all the way down to 0.0. In this physical world, when you set a stove burner to 0, you are dropping it to a completely cold, non-boiling state. But inside the logic of an AI model, a temperature of 0.0 represents a state of absolute IC mathematical certainty. Let's trace what happens to the data variables inside the server memory logs when you send a prompt under this condition. When you input a sentence, your AI model does not look at the text as a collection of human ideas. Instead, its internal mathematical layers evaluate thousands of potential tokens that could logically follow your text. It assigns a raw numerical probability score known as logit to every single token in its vocabulary. For example, if your input text is pursuant to company policy, all expense reports must be submitted by Friday at 5 p.m. to the department. The model's internal engine creates a long mathematical distribution vector array. The token manager might be calculated with 85% probability weight. The token director might receive a 12% probability score. The token assistant gets 2% score. And a completely unrelated token like pineapple receives a 0.0001% score. When the stove burner is locked at a temperature of 0.0, the system executes what engineers call greedy decoding. The model is completely forbidden from exploring alternate options. It behaves like a strict compliance officer who refuses to tolerate even a single millimeter of variance. It looks at the mathematical array, identifies the single token with the absolute highest probability score, in this case manager, and it selects that token with 100% consistency. If you reset the server, clear the cache, and send that exact same prompt 100,000 times in a row, the temperature setting of 0.0 guarantees that the model will return the exact same word-to-word response every single time. It completely eliminates entropy. The data traffic logs shows a perfectly narrow, highly ranked choice without calculating alternative paths. This is the low simmer state. It is the ideal configuration for processing structural data, auditing financial ledger sheets, extracting data from legal disclosures, or translating technical manuals where an imaginative variation is a literal compliance failure. Now, let's reach out and grip the control dial in our stove and spin it all the way up to a temperature of 1.0. In our kitchen analogy, you have just cranked the stove burner to a blazing high flame setting. The water inside the pot instantly begins to furiously boil and churn. The thousands of lettered token tiles are caught in chaotic high energy vortex, bouncing off the walls of the pot and leaping towards the surface in a completely unpredictable pattern. Mathematically, what happens inside the Anthropic engine at a temperature of 1.0 is fascinating. The system still calculates the raw logit scores for every token. The word manager still starts with the 85% advantage, but the high temperature setting activates a mathematical smoothing function that actively flattens the probability curve. It deliberately reduces the gap between the top ranked option and the lower ranked options. The 85% probability of manager is mathematically compressed down to perhaps 30%, while the lower ranked words like director, assistant, or even creative choices like captain or architect have their mathematical probabilities artificially elevated. When the model selects the next word under a high flame configuration, it is no longer using greedy decoding. Instead, it sample picks from the flattened probability distribution array. The highest ranked choice is still an option, but the lower ranked, highly unexpected words now have a genuine fighting chance of being selected by the system's processor. If the model picks an unexpected word for its first token, that choice completely shifts the mathematical calculation for the second token, sending the entire text generation sequence down a completely different creative pathway. This is how wild imagination is engineered inside a computer network. The server traffic logs during a high temperature run shows a vastly more complex computational paths, because the system is constantly calculating word combinations that steer away from standard historical text patterns. If you send this exact same prompt to the model 10 times in a row at a temperature of 1.0, you will receive 10 completely different, highly varied, distinct narratives. This high flame configuration is magnificent for creating copywriting, product naming brainstorms, screenwriting, or designing fictional marketing personas where you explicitly want the system to avoid predictable cliches. But if you accidentally leave the burner on high flame when you are processing an internal legal policy update or a client contract, that mathematical smoothing function will allow lower probability, inaccurate tokens to leap into the text stream, generating highly polished, completely confident lies. You have forced the system to prioritize creative flair over absolute empirical truth. Now that we have deconstructed the deep backend engineering of token probability curves and stove burner dynamics, let's step up our operational desk and build a complete, linear, live enterprise case study from scratch. We are going to design an automated customer engagement and data triage pipeline for a fast-growing regional real estate and property management firm. Our objective is to build a digital assembly line that handles incoming inquiries from a public web form and routes them through our automated systems. But here is the architectural challenge. Our incoming data stream is completely mixed. Some submissions are urgent maintenance emergencies. Some are tenant billing disputes that require hyperliteral accurate analysis. Other submissions are prospective buyers asking for creative, engaging description of luxury properties or community marketing insights. If we use a standard single-tier AI setup with a fixed default temperature, our system will fail. If we lock the system at a lower temperature, our marketing responses will sound like dry legal compliance briefs that bore prospective clients. If we set the system to a high temperature, our billing dispute logs will contain made-up figures and invented policy guidelines. To scale operations safely, we must construct a multi-tiered conditional no-code workflow using an enterprise automation platform like, let's say, N8N or Make.com, connecting directly to the AI's API endpoints. Let's build the assembly line step by step, tracing the digital button as it moves across our architectural map. The relay race begins at a trigger event. A client visits the property management website and submits an entry via the public intake form. The form contains 4 specific text fields: first name, email address, inquiry type, which is selected via a drop-down menu containing options like maintenance, billing and marketing, and a large text field titled message body. The moment the user clicks submit, the website infrastructure packages this data into a secure text payload and hits our no-code platform. The system picks up the button instantly, parsing the text string without human intervention. The data payload moves directly into a conditional router node. What is a conditional router node? It is a decision-making step in a workflow or AI pipeline that directs the execution path based on predefined logic, variable values, or AI-generated intent. Meaning, this node acts as a traffic controller of a digital assembly line. It reads the data field labeled inquiry type. If the field contains the text string maintenance or billing, the router directs the button down path A, the low simmer compliance pipeline. If the field contains text strings like marketing, the router switches the track, directing the data payload down path B, which is the high flame imagination pipeline. Let's follow the data down path A. The payload hits a request node configured to communicate with the AI's API endpoint. We are sending a structured request to the model. Let's verbally map out the configuration parameters inside the data payload. First, we define the target model parameters and the model type. Next, we configure a system instruction block to lock down the operational guardrails, explicitly instructing the system to function as a hyperliteral data extraction clerk. Then, we reach down to the critical parameter configuration line. We type out the key label temperature, and right next to it we set the numerical value to an absolute uncompromising 0.0. Finally, inside the user message field, we pass the raw text from the form's message body in explicit delimited tags like tenant input. Because the temperature variable is locked at 0.0, the AI's engine activates its strict greedy decoding process. It reviews the messy tenant text, ignores all emotional fillers or dramatic language, and extracts only the empirical facts: the unit number or the specific leaking pipe location or the precise dollar amount in dispute. The model is mathematically blocked from inventing policies or generating conversational fluff. It formats the data into a clean, unpredictable key value text list and passes the baton to the next node, which seamlessly writes the verified information into the company's core internal accounting ledger database. Now, let's reset and trace a different submission than the router directed path B. A prospective home buyer has filled out a form asking for a compelling description of a new listing in a historic neighborhood. The data hits a separate request node linked to the exact same AI model. But look at a configuration payload this time. The model parameter remains identical, but our system instruction block is shifted completely. We instruct the model to act as an elite, charismatic, luxury real estate copywriter. We move to the configuration line, locate a parameter label, temperature, and we deliberately set the numerical value to a high expressive 1.0. Inside the user message block, we feed the raw property dimensions, the number of bedrooms, and the neighborhood name. When this request executes, the high temperature setting flattens the probability curve inside the processor. The system actively avoids predictable, overused real estate phrases like charming house or great location. Instead, it sample picks from its flattened array, selecting vivid, unexpected adjective sequences like architectural masterpiece tucked away in a sun-drenched corridor. It generates completely distinct, high-converting marketing hooks in seconds, passing this creative text down the assembly line to an automated email marketing engine that drafts a personalized message back to the prospect. We are reaching the final miles of today's journey here, and it's time to take this enterprise architectural theory and run a direct diagnostic test using your own voice or fingers before you step away. I want you to open up your preferred AI application right now and step directly into its text or live voice interaction portal, whichever you are comfortable with. We are going to execute a precise dual stage prompt framework designed to force the underlying model to demonstrate its internal temperature calculation shifts right in your ears or eyes. I want you to speak or type this exact script block into your app. We are running a multi-stage parameter analysis to map your internal token selection logic. Stage 1. I want you to act as a cold, deterministic, zero entropy data extraction tool. I'm going to give you a single phrase. Your strict instruction is to output only the names of any cities mentioned in my text. Do not include a greeting, do not include an introduction, and do not provide a conversational commentary. If no cities are found, output the single word none. Here is the phrase. Our regional expansion team evaluated 3 separate commercial logistics warehouses located near the shipping ports of Rotterdam and Antwerp last quarter. Begin stage 1 now. When you submit this instruction, pause and observe the processing output. If the model is executing properly under low temperature logic, it will suppress all human pleasantries and return a clean, instant, sterile text string Rotterdam, Antwerp. The moment the text displays, immediately issue this second highly contrasting verbal directive without opening a new chat window. Now execute stage 2 of a parameter analysis. Shift your schematic generation weights to represent an absolute high entropy temperature value of 1.0. Act as highly imaginative science fiction writer. Take those exact 2 cities, Rotterdam and Antwerp, and weave them into a surreal, poetic 3-sentence description of a futuristic floating metropolis built out of recycled stardust. Use unexpected, low probability metaphors and completely avoid standard sci-fi cliches. Begin stage 2 now. Watch the screen or listen to the audio voiceover response generate this second step. You will see an immediate structural explosion of language. The model will completely abandon its cold, robotic persona and deliver a dense, highly varied, artistic narrative texture that feels completely human in its creative unpredictability. You are watching the stove burner turn from low simmer to high flame in real time. As we near the end of today, I want to leave you with a sharp, professional directive that challenges how you view operational scale. Most executives look at artificial intelligence as a binary tool. They think it either works or it doesn't. They spend thousands of dollars buying expensive corporate software packages only to abandon them because the output feels too rigid or too unreliable. But as a leader, you must understand that the true power of automation lies in parameter awareness. You are the architect of your digital workforce. Stop accepting default configuration from your software vendors. Stop allowing your engineering team to hide the underlying parameters behind fixed, unoptimized user portals. Demand absolute visibility into the settings of your API endpoints. Know when to lock the system into a cold mathematical zero to protect your company's data integrity, compliance, and legal liability. And know exactly when to turn the dial to a blazing 1.0 to unleash the full competitive creative power of human-machine collaboration. The stove is hot, the tokens are churning, and the control dial is resting entirely in your hands. Go optimize your workspace infrastructure, and I will see you next time at the AI desk.